Alright, ladies and gentlemen, welcome back to 5 Minutes of Math. This is Mr. Lunsford, and I am glad you joined me this evening. Tonight's homework is for the evening of February 26, 2018, and we're looking at composite shapes. Let's get started. For number 13, we're looking at two rectangles, and we want to find the shaded area. But in this case, we have superimposed one shape on top of another one. Superimpose just means you put one shape on top of another. You're just stacking them up. And they want to find the area of the pink portion here. So if we're looking at this, it's the outer rectangle, which is the larger one, minus that blue inner rectangle gives you the area of the pink region. So we know our formulas for the rectangles are just length times width, A times B. So where am I going to get my numbers? So we have 42 times 25. That's the area of the outer rectangle, 42 meters across the bottom times 25 meters up the side. And then we have our inner rectangle, which is 20 meters tall and 22 meters across the bottom. So our outer rectangle's area is 1050 minus 440, which is the area of that inner rectangle, and that's going to give us the area of that pink region. Now we subtract those two, we get 610 meters squared. That's the area of that pink region. For number 14, we're looking at two triangles that have been superimposed on top of each other. All right, so two superimposed triangles. The larger one is 10 yards tall and 15 yards long. The smaller one, the blue one or the blue-green one, is 6 yards tall and 9 yards long. So if we subtract those two, the book is looking for the area of the shaded yellow portion. So if we're taking a look at this, we have the outer triangle, the 10 by 15 one, minus the inner triangle, the 6 by 9 one, and that's going to give us the area of the yellow region. Well, the formula for a triangle is 1/2 base times height, and I'm just going to change that to 0.5 base times height. Okay, so we're going to fill in our blanks. 0.5 times 10 times 15, that's our yellow triangle, minus that inner triangle, 0.5 times 6 times 9. So again, that height is 10. Here's the base is 15 for the outer triangle, and that's again the big one. And the inner triangle is the height is 6 and the base is 9. All right, so that's the inner triangle. Subtract those two, you get what's left. And here's the 0.5 times 150 minus 0.5 times 54, and we have 75 minus 27, and that's going to be 48 yards squared. That's the area of that yellow region, 48 yards squared. That's it for number 14. Number 15. Now I know you all remember this strategy. Here's another octagon. In this particular case, though, the center is a little bit longer than those segments on the outside. So we can use a similar strategy, but it won't be exactly the same. Now, we have the nice little convenient triangles up here at the upper right-hand corner, upper left-hand corner, and the lower right and left-hand corners. So we can still subtract our two smaller squares. And if you're not sure what I'm talking about, go back and look at our octagon problem that we saw a day or two ago in our 5 Minutes of Math. So we have a rectangle, the giant rectangle that covers the entire area of that octagon, that 8 by 16 area, minus the small square at the top, minus the small square at the bottom. That's going to give you the area of the octagon. So here's our big rectangle, the 8 times our 16, and that's going to be the giant portion of this that could just perfectly covers our octagon, minus the small square at the top, which is a 2 by 2 square that comes from those two blue triangles, minus the small square at the bottom, which is another 2 by 2 square, and that's going to give you the area of that octagon. So let's simplify. 8 times 16 is 128, minus 4 equals the area of the octagon. Now the problem gets really, really simple. We have 124 minus 4 equals the area of the octagon, and 120 centimeters squared is the area of that octagon. That's it. That's all there is to this. Y'all take care, and remember, Math is not just about numbers, it's about the relationships that surround us every day. Have a good one.